Okay, so last transformation we're going to look at is what's called a period change. Okay, period change, that's when you're stretching or compressing horizontally. All right, so when we take the normal graph of sine and we draw it, there's a certain distance you have to travel before it will repeat. That distance has been the same for every transformation all week. Okay. Taking this graph, just make a copy of it, and shifting it up, shifting it up or down, that doesn't change how long it is. Okay. Shifting it left or shifting it right, it still does not change how long it is. And then taking that graph and stretching it up or down, still doesn't change how long it is left to right. So we have never changed the length left to right. Does anyone remember what the length is from here to here? 2 pi. Yep. So this has a length of 2 pi from there to there. What's that in degrees? 360. So that's been the length of every graph we've done so far. Okay, what we're going to look at is what happens when we stretch or compress them. So what operation did we already kind of figure out it's going to be? It's going to be multiplication because it's a stretch, and it's going to be where? Inside. So it's going to be inside. So we're going to write it like that. It's going to be multiplying by a number on the inside. Okay, those are all examples of horizontal stretches. So 2 things we look for: multiplication, right, it's 4 times x, and it's inside. Will, can you just put that for me? Of course. Thank you. Yeah, so that's the horizontal stretch or compression. Now, depending on the number you put in front, it's going to do one of 2 things. It's going to stretch it or it's going to compress it. What happened when we did a horizontal shift? Was it backwards or was it not backwards? So like if I do something like, let's get rid of this one.
I thought vertical was normal.
Yeah, vertical is normal.
The vertical was normal. So if I do like sine of x plus, I think we did ones like pi over 2. A plus, you would think positive numbers, they go to the right on a number line. But which way is this really going to shift it? Right, that's going to shift it to the left. Let me just fix my zoom. I'm zoomed in too much for you to really get a good picture. So that's what happens when you shift it to the left. The original, let me show you that one. You're going to see the original, if I do that, a little bit to the right. So the blue one is a little bit to the left. Okay, it moved left. What do you think is going to happen if I put a 4 in front? Do you think it's going to stretch the graph, or you think it's going to compress the graph? Do you think it's going to stretch it? How come? Okay. Anyone else have a thought?
Compress it.
How come?
Half the length.
Well, why do you think a 4 is going to compress it?
Oh, I thought you were talking about the one on the calculator. Not 4 would make it longer.
You think the 4 is going to make it longer?
Yeah.
Because 4 is a bigger number? Okay. Well, let's try it. Here's sine x, and let's do sine 4x. So there's the original, and there's sine 4x. So what did the 4 actually do?
Shrank it.
Yeah, it compressed it, right? Compressed it down.
I knew that.
You did? Yeah?
Yeah.
Now, what number did I put in front to do that one? 4. So let's look at the graph. Let's just kind of block off one section of the blue. Okay, it goes just like that. That's one section of the blue. Now, count how many red sections you got. 1, 2, 3, 4. So by putting in a 4, it squished it 4 times as much. If we did a, let's see, what's the other one? If we did a 2, that would squish it half as much. What do you think would happen if we did a half?
It'd be half as long.
It would expand because it's less than 1.
Right, it's going to stretch. Okay. So if you put in, it's just easier for me to do 0.5. Okay. Here's the original. Now look at the 0.5. It's stretched. Okay, it got longer. Okay, so this is a transformation where the opposite happens from what you would expect. The bigger you make this number, the more squished the graph gets. The smaller you make that number, the bigger the graph gets. Okay, so it does the opposite of what you would.
What about negative numbers?
For this, we're just going to look at positive, but a negative would cause it to flip.
Okay.
Yeah, but we're just going to look at positive. Okay, so when we are doing a period change, the graph is stretched or compressed horizontally. Okay, that's the x-axis. We take a graph like that. Let's make a copy of it. Make it a different color. If I take that green graph and I don't stretch it up and down, just compress it. This dot that was originally right here, that was the last peak. That one got compressed all the way to over here. What about the coordinate would have to change to move it that way? The x. What happened to the y value? It stayed the same. Okay, it's at exactly the same height it was before. It just moved to the left because it compressed. Yep. Okay, so when is it going to, what kind of number do you think is going to cause it to compress in general?
Anything above 1.
Anything above 1. Yep.
1 stays the same.
So anytime that it's above 1, it will compress. If it's between 0 and 1, it will stretch. If it was less than 0, it would cause it to flip and stretch. But that's not something we're going to look at. Okay, so it's the opposite of what you would think. You'd think a big number would make the graph bigger. No, the bigger you make the number, the more squished it gets. The smaller you make the number, the more stretched it gets. And you can't make it a 0, because if you make it a 0,
It's gone.
then you've wiped out the weight. It's just a horizontal line. So it's got to be somewhere above 0, but it could be anything you want, fraction, decimal. All right, so now we looked at a little bit with sound yesterday. We saw if you took a wave like this and we did something like this to it, what did that do to the wave when you stretched it vertically? In terms of how you heard it.
Made it louder.
It made it louder. Yep. So now, if we take a wave like that and we compress it or stretch it horizontally, what do you think that's going to change? That's going to change the pitch. Yep. So let's try an example of that. All right. So one thing that we're going to have to do in this section, something like we did yesterday, we're going to be asked to find the period. Okay. So yesterday I asked you to find the amplitude in some problems. You didn't have to graph it. Okay. All you have to do is take the absolute value of the number in front. Okay. This is the formula to find the period. Okay, so when you stretch or compress it, and I ask you, how long does it take for one cycle? How long does it take for the graph to do this? What is that distance? That's the formula to find it. You take the original length, which is 2 pi, and you divide by b. And b is whatever number you put right there. So 2 pi divided by b will tell you the new length of the wave. Right, so let's try that on a few. So these are not graphing. Okay, we'll do graphing at the end. But this is just finding the period. Okay, so sine 2x. So to find the period, the formula is 2 pi divided by b. What is the b in this case? 2. Okay, it's the number that's in front of the x. What's 2 pi divided by 2? Pi. If the original graph had a length of 2 pi, this has a length of 1 pi. Is this longer or shorter? It's shorter. It's half as much. And that's because when you put a 2, it causes it to compress. So that's the new cycle length. That would be like a higher pitch. Okay. How about this one? What's the formula that we use to find the period?
T equals 2 pi over b.
So you do 2 pi over b. You need to fill the b in. What's b in this case?
5.
5. So if we were to draw this one, this graph would be compressed 5 times as much. Okay, that's the new period length. All right. What happens when you put a fraction in? That causes the graph to do what? Expand, right? It's going to get longer. So the new period now should be bigger than 2 pi. Okay, 2 pi is kind of your base, and then it gets bigger or smaller from there. All right, let's see what happens here. All right, what's the formula that we use to find the period?
2 pi over b.
So 2 pi over b. And instead of dividing by a fraction, what can you do?
0.25.
Multiply by what? So yeah, multiply by 4. Right? Instead of dividing by a fraction, you multiply by the, does anyone remember the word? Reciprocal. Yep.
Can't you just do 2 divided by 0.25?
That's the same thing. Yeah. 2 divided by 0.25. What's 2 pi times 4? You go straight across.
8 pi.
8 pi over, if you want to think of that as having a 1. 1 times 1.
1.
It's just 1 at the bottom. So that caused the period to get 4 times as big, which means if it originally did something like that, now you stretch it out and it's going to be 4 times as long. All right. So any question on how to find period using B? All right, so then the last thing is the sketch. First thing we should figure out is what stays the same, which I think we did on our chart right here. What values are going to stay the same when we stretch or compress left and right?
Y.
The y's. Okay, unfortunately the y's are the easy numbers. 1s, 0s, and -1s. This time, we can't work with the 1s, 0s, and -1s. Okay, we have to work with the x's. Let's look at this graph. If I take that graph in green and just leave it the way it is, where does it start on the x-axis? 0. Let me compress it.
0.
Where does it start now?
0.
still starts at 0. And let me stretch it.
0.
Still starts at 0. So no matter how you stretch or compress the graph, the first x value is always going to be 0. Now, the only reason that's true is because in the problems I'm giving you, there's only one transformation in each problem. If I gave you a problem where it shifted it and stretched it at the same time, this would not be true. Okay. But for us, it will be. Okay, so no matter how you stretch or compress it, because there's only one transformation I'm giving you, the first x coordinate is always 0. Okay, the next one we're going to find is this one. What do we call the distance from here to there? What's the name of the distance all the way from here over to here? It's the something of the graph. We have two different words for it.
Is it amplitude?
The amplitude is the height of the wave.
Is it period?
It's the period,
Or the
yes.
cycle?
Well, the cycle, yep. So from here to here is the period. So the next thing you want to find after you find where the graph starts, which is always 0, is you want to find where it ends. Where it ends is at the length of one period. That's where it ends. How do you find the length of one period?
2 pi, right? No.
Well, one period, if you don't do anything to it, is 2 pi. But what if we do something to it? How do we find the new period?
2 pi over b.
2 pi over b. Yep. That's how you find the end coordinate. So once we get to step B, you're going to have something like this. You're going to know where it starts. You're going to know where it stops. The next thing we're going to find in part C is the middle. Now remember, all the points are equally spaced. If you have 2 points, or 2 numbers, how do you get the number that's exactly in the middle of 2 other numbers? You divide them by 2? That's part of it.
What was the question?
How do you get, if you have 2 numbers, which we're going to have,
You add.
how do you get what's exactly in the middle?
You add, divide by
You add them and divide by what?
2.
2. What's that called?
Averaging.
The what?
Averaging.
Yeah, the average. So once you have the beginning and the end, you average those 2 to get the one in the middle. That's what we're going to call the third one. First point, third point, fifth point. So the average of the first and the fifth will give you the one in the middle. Next, we need the second point. That's right there. How do you think you would get the second coordinate? It's going to be based on what you've already done. You're going to need what you did in part C to get the second one. Do what with the first and the third?
Find the average between them.
Yes. Second one is exactly halfway between the first one and the third one. So you're going to average the first and the third, and that will give you the second. And how do you think you're going to get the fourth one?
Average the same thing.
Average what?
Average of 5, 3.
Yeah. Average of the 5 and the third one. Yep. So there's the second one. That's the average of the first and the third. And the fourth one is the average of the third and the fifth. Okay, that's what's nice about these 5 points. They're all equally spaced. So if you know 2 of them, you can always find the one in the middle by averaging. Okay, so again, the order you want to go in is find the beginning. Beginning is always what number?
X or 0.
0. Find the end. That's using the formula 2 pi over b. Then you can get the middle. Then you can average those two and see what's there. Average those two, and you'll get that one. And that'll give you your sketch. Okay, anyone need any of those steps? There's 5 steps because there's 5 points. Good. Okay. So let's try this one. All right, so now we know all the different transformations. First thing you have to do on the test is identify what kind of transformation it is. All right. First thing, what kind of arithmetic is in this problem? Adding, subtracting, or multiplying? It's multiplying. Okay. Multiplying means it's a stretch. So we know it's some kind of stretch.
And it's on the outside.
Is it on the inside or the outside? Inside. Right? Pretend like you had parentheses around your argument. If it's inside the argument, that means inside. If it's outside the parentheses, that's what we mean by outside. When it's inside, what kind of stretch is it? That's horizontal. Inside means horizontal. Multiply means stretch. Horizontal stretch. Okay. Which column is going to stay the same? The y's. Yeah. And what are my y's for sine?
I got that one.
Not the same as cosine.
0, 1, 0, negative 1, 0.
Yep, that's perfect. And now, first x value, whenever we're doing a stretch, is always what number?
0.
0. So you can get those 6 without really any arithmetic. All right. There's our first x value. What's the next x value we do?
The 5th coordinate.
Yeah, we got to do the 5th one down here. What is the formula to find the 5th one?
2 pi over b.
2 pi over b. That's going to tell you the length of one cycle. That means you're going to know where it ends. That's what you need, where it ends. What's the length of our cycle in this problem? Pi. Okay, so now we know where to start. We know where to stop. After we get those two, which one can we do? The middle, the third one. How do you get the third one if you know the beginning and the end?
The average of the first and the 5th.
Yeah. So if you average 0 and pi, you get pi over 2. Okay. Anytime you average something with 0, you just take half of it. All right. So
Then
now
we
we
can find the 2nd coordinate,
now we can get the second one,
which is the average of the first and third.
which is the average of the first and the third. That's pi over 4. All right. And
then
now, how do we get this one?
the average of the third and the 5th.
Average of the third and the 5th. Now, that one might be a little tricky because we got to do, we got to add them up, and then we have to divide by what?
2.
So let's add these together. And instead of dividing by 2, I'm just going to think of taking half. That's the same thing. If you divide something by 2, you get half of it. To add these together, what do we need to have? So what do we need here to add those up?
2 on the bottom.
We need to make the bottom a 2.
So I made a 2 on the top.
So we put a 2 on the top.
So that would be 3.
3 pi over
2.
2.
And then
And now that's when you add them up. Now you need half of that. What's half of 3 pi over 2?
3 pi?
3 pi over 4. Yep. Those are your x's. Now, if you wrote them with a common denominator, you'd see a pattern. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. But because it's 4 pi over 4, the 4 is canceled. That's why we just have pi. There's always a pattern. Okay. Questions on how we got the x values? Now, this graph as I did as I was kind of going, I could pretty much just use that. All I have to do is label it. Every sine function is going to look like that today. Just put in your labels. What's the highest and what's the lowest?
-1 and 1.
Let's put those in. First one was 0. What was our next x value?
Pi over 4.
1 pi over 4. Next one is 2 pi over 4. This one?
3 pi over 4.
We'll put that one up there.
And then pi.
And then pi.
Is that going to be like that homework, Jen?
Yeah. So all the graphs of sine, they generally look like that. So check your points. 0, 0. Pi over 4, you're at 1. Back to 0. Just put that one in, -1. And the last one, you're back up at 0. Okay. Did that graph stretch or did that graph compress?
Stretch.
Compressed. Right? Normally, how far do you have to go to get a full cycle in? You normally have to go all the way to 2 pi. We got a full cycle in by just going to
Pi.
1 pi. Yep. So it compressed it in half. Yep. That'd be a higher or lower pitch if it compressed? Higher. It's a higher pitch sound. Yep. Okay. Any question on that one? All right, let's try this one. First, just by looking at it, let's see if we can identify the transformation. Which one is it? Vertical shift, vertical stretch, horizontal shift, horizontal stretch. How come? Inside multiplication. Inside multiplication tells you horizontal stretch. Okay. What column is going to stay the same?
Y.
Okay. And
Sorry, what is outside multiplication again?
outside multiplication, like over here, that would be a vertical stretch.
Right there.
That was yesterday.
Your y's are 1, 0, -1, 0, 1.
Okay. So my y's are 1, 0, -1, 0, 1. No matter how you stretch or compress, because I'm only giving you one transformation, first x value is 0.
And then we find the average, or we find the fifth coordinate using 2 pi divided by b.
Okay, we got to find where this ends, and then we can do our averaging.
Wait, is B just the number that changes in the
Yes.
division? Or the
So b is the number that's in front of x. So it's 2 pi, I think we did this,
Yeah.
2 pi divided by 1/4. Remember we do it as multiply by 4? So what's 2 pi divided by 1/4?
8 pi.
8 pi. Is that bigger than the original cycle or smaller? Bigger. It's stretched a lot bigger. Okay, you got to go 4 times as far now to get one cycle.
Oh, so this one be easy.
So yeah, what's in the middle of 0 and 8 pi?
4 pi.
And then in the middle of 0 and 4 pi?
2 pi. And then 6 pi.
In the middle of 4 pi and 8 pi?
6 pi.
6 pi. Yeah. Okay. So that's one where the averaging works out pretty nice because you don't have any fractions. Okay. Now this graph stretched 4 times as big. When I sketch it the way I've been doing it, is it going to look 4 times as big? Why not?
Because you're changing the scale.
I'm going to change my scale because I don't want to have to stretch it 4 times as big. So this is going to be 0. And that is normally our whole graph. Okay, the original graph would fit right in here. That's the original. Now we're going to stretch that out 4 times as much. So it's going to be 4 pi, 6 pi, 8 pi. 1 and negative 1 are going to be our y's for everything today. So we're up at 1, 0, negative 1, 0, back to 1. Okay. Doesn't look stretched, but it is because I changed my scale. Okay. Since we stretched it, higher pitch or lower pitch sound? Yeah, much lower pitch because we stretched it out. Okay. Any question on the table or the sketch?
No.
Okay. I know I've said it a bunch of times, but some people didn't do it in the homework. The table is worth 10 points. So if all you do is the sketch on the test, you're going to lose 10 points on every graph problem because you didn't do the table. Okay, so the table is the most important part.
Yeah, right.
Do we have another worksheet?
So yeah, we got one more example, and then tonight is a worksheet. Yeah.
Can you print it out again?
Yes. And this test going to be online, right?
Like normal?
Yeah, it'll be just like we always do.
So the graph's just going to be like a fill in the blank kind of sequence.
The tables are going to be like a fill in the blank, and the graph will either be like a matching or identify a coordinate kind of thing.
We're not going to be drawing, like
No, it won't be like a plotting thing. But you will have to know what the graph looks like. Okay, let's look at this one. What kind of transformation is this one?
Horizontal stretch.
Right, it's inside the parentheses,
And it's multiplication.
and it's multiplication. Okay, even if they wrote it like this, that's the same problem. There's no difference. If you're doing something to the x, doing something to the x means inside. If you're doing something like this, that is not doing something to the x. That's outside. Okay? So you may not see parentheses like that. Okay? If I had this, is that inside or outside when you put a +2 on the end?
Outside.
That's outside. Okay? If you want to put the parentheses, that makes it clearer. The only way that it could be inside is if you did that. Okay? Just to be clear on that. Okay, so what column is going to stay the same?
Y.
Okay, what are my y's?
0, 1, 0, negative 1, 0.
And because of the kind of problems that I'm giving you, the first x for this transformation is 0.
And then we find the fifth coordinate, and we do 2 pi over b, which is pi over 2.
So 2 pi.
Over pi over 2.
Okay, now instead of dividing by a
We
fraction,
can multiply by the reciprocal.
multiply, what's the reciprocal?
2 over pi.
2 over pi. What happens when you do that?
They cancel out.
The pi's cancel out,
And it'd be 4.
and the cycle length of this graph is just a 4. No pi.
So then would the middle be 2?
For 0.
So it ends at 4,
1, 2, 3, 4.
and then the middle would be what?
2.
2,
And then 1.
1,
And then 3.
and then 3.
How would we mark?
Okay. So when we first look at this one, you might be looking at that number and think it's a pretty bad number to have in front of x because it's got a pi in it. But it actually cancels out the pi from all the x's. And this would be the only problem we've done this week. If you don't label anything on your axes, you could still get it all full credit. Because I'm going to go by 1s on everything. If you want to put your labels in, you can.
Is there going to be a room on like the test to label?
Yeah, you'll have the graphs will be on the test. Yep.
Okay. But like, will it let us write?
If it was something where you had to graph by hand, yeah, you would be able to put your own labels.
Okay.
Yep, just like you do right here. Okay, so I'm going to go 0 to 4. My highest is 1. My lowest is negative 1. What is my first coordinate? 0, 0.
1, 1.
1, 1 right there.
2, 0.
2, 0.
3, negative 1.
3, negative 1.
4, 0.
4, 0. There's our sketch. Okay. Any question on that one? So I'll just show you one other thing you can do with a frequency on a cell phone. I'm going to show you something. One other thing you can do. So the homework will be a worksheet. I'll print that out after. Okay, and remember, tomorrow is a review. Yeah.